So, hello everyone. My name is P. Sai Surya. I'm studying in KL University, and today I want to brief you about Introduction to Principal Component Analysis (PCA) in this video, and I want to give you a brief explanation about this as I'm the paid mentor of DDS course in this 2 semester. uh, the principal component analysis (PCA) is a statistical procedure used to reduce the dimensionality of data while preserving the important information. So, by transforming the data into a new coordinate system, as seen in this graph, PCA helps in identifying the patterns and the relationships. So now, for understanding the mathematical concepts beside the principal component analysis (PCA), it is a mathematical technique that is used to reduce the dimensions of the data set while preserving its essential features mainly. And so this transformation allows for visualization and analysis of complex data sets, making it a powerful tool in data-driven AI systems. So applications of this PCA in the data-driven artificial intelligence systems is that it can enhance predictive modeling using closuring techniques and it reducing dimensionality to improve the computational efficiency. And the advantages and the limitations of the PCA. So the advantages are that it efficiently reduces the dimension of the data while retaining most of the variation. So there are also the limits of the PCA. It struggles with handling non-linear patterns in the high dimensional data. And of course, there are trade-offs also in the PCA, which requires the data to be linearly correlated to the optimal performance. So PCA versus other dimensionality reduction techniques. The PCA mainly focuses on the directions, that is principal components in the high dimensional data, whereas other techniques like LDA emphasize preserving the local structures or discriminative information. So in PCA it is often used for feature extraction and the data compression, whereas in other techniques there may be non-linear and computationally expensive but can capture more complex relationships in the data. Pre-processing data for PCA. As shown in the below, there are 7 steps in this. Before applying the PCA in this, it is crucial to pre-process the data to ensure the accurate results. As seen in the step 1, there is a collection of transcriptomic studies, and in the step 2 there is normalization, pre-processing and supervised analysis, and like that until we continue to the step 7, it proceeds into the prospective validation. Additionally, handling missing values and outliers is the vital for the effectiveness of the PCA. So implementing PCA in Python using learn is that there are library, steps, variants, and the components. So in the library, we utilize the skit library in the Python for PCA implementation. And in the components, we explore the principal components on their impact on the data. The steps are nothing but it imports the PCA module, prepare the data, and fill the PCA model. And while interpreting the PCA results, we have cluster analysis, explained variance, loading vectors. In the cluster analysis, it is simple, nothing but PCA scatters plot. As in the graph, it can reveal clusters. As in the explained variance, as shown in the above, it understands the explained variance. And in the loading vectors, it interpreting the loading vectors. Real world examples of PCA in the artificial intelligence systems are it is face organization which we uses in the daily life and recommendation on the systems and mainly medical imaging analysis and also for the financial forecasting. Briefly, in the facial recognition, PCA is used to reduce the dimensions of the facial features, allowing for the efficient storage and the recognition. As well as in the medical imaging analysis, PCA assists in extracting the key features from medical imaging data sets. And the conclusion finally and the future directions for the PCA in the AI is improved model performance, optimizing computational efficiency, integration with the deep learning. In the improved model performance, it is utilizing the PCA for enhanced predictive accuracy. And in the optimizing computational efficiency, it reduces the computational complexity with PCA. And in the integration with the deep learning, exploring PCA's role in the deep neural network architectures. As the AI systems continue to evolve, the future of PCA lies in maximizing model performance, and these advancements can significantly impact the scalability and the interoperability of the artificial intelligent models. So that's it, guys. Thank you for this opportunity.